In this video, we're going to dive into what a scope chain is, and you should get a much more intuitive idea of how scope actually works under the hood. Before we get into that though, I'd like to revisit another idea of a chain that we've looked at before in the objects class, namely the prototype chain. If you recall, we can create an object like we've done here and have it inherit from another object by using a method like object.create. And so our object inherits from my prototype. And when we call the parent property of my object, the JavaScript runtime begins a lookup process. And it starts off with the immediate object right here, or the own object, and then looks through all these properties, and if it can't find it, it navigates up this chain, or this link of prototype objects, and then it looks at this object and sees whether it can find the property there. And so once it finds the property, it returns its value, and in this case, the value is a string, and you can see that here. And so you can see this in debug format over in the watch expressions where I've typed in my object and drilled into it so we can take a look at what the prototype pointer points to. And so this is an example of a data structure that is being used by the runtime. So in other words, JavaScript is doing this for us, even though we haven't written the code explicitly to set up these structures. And the runtime is performing this lookup process anytime that we try to access a property on an object, like this parent property of my object. And so I wanted to revisit this concept because the way that scope chain lookup works is very similar, except it's for variables. So for the rest of the video, we'll talk about the scope chain and how JavaScript does variable lookup. Similar to the prototype chain lookup, now we're going to look at scope chain lookup, and that's going to be the lookup of variables, like these variables A and B. Now, this might seem like a silly topic or one that you don't really need to know, but I think having a visualization for what's happening here will really help you down the road when we get to some more advanced patterns like using closures on variables. So the way this will look is we'll have a few objects. They're going to be called scope objects that will look very similar to a prototype object. And the scope object will have the identifier name, like the variable name here, and some value. And so you can very much think of scopes as objects. And so to start getting a better feel for this, what we can do is start drawing out the scope objects for this code here. The first place we'll look is what happens when this function here gets created. Well, when JavaScript sees that we want to create a function, it will create the function on the heap like we've seen before, but it will also attach a scope object to it, and that scope object will contain some variables and maybe a link to another scope object. So in this case, let's draw out what that scope object looks like. I've drawn this table to represent the scope that exists at the time that our add function gets created. And so here's where the add function gets defined. And at that point, there's a scope that exists already. And the scope has one variable in it with an identifier of A and a value of 10. So you can start to think about these scopes as just objects with key value pairs, where the key or the identifier is the name of the variable and it has a value. So the important thing to note here is that this scope object gets attached to this function at the time that the function is created, and it follows the function around wherever it goes. And since it gets created, the scope object gets created when our function gets created and it doesn't change, this is called a static scope. Or sometimes you'll hear it referred to as a lexical scope. And the reason for that is the scope chain or the scope objects are defined in the order in which the code is written. And so because we create the function here and the variable A was defined up here, the scope that gets attached to the function is the scope that's up here. So, and it doesn't change as we call the function. So next up down here, what happens is we actually call the function. And so the JavaScript runtime enters into the body of the function and executes the code here. At this point, another scope is going to get created at the time that we call the function. Sometimes this is going to be called local scope, as you'll see in the debugger in a second. Or it might be called the activation object for the function, and it gets created each time the function gets called. So I've drawn another scope object here, which I'll call the local scope, and inside of that will be any of the variables that are visible inside of this function here. And so that includes any named function arguments here, and it includes this arg, and we have another variable here called b, which is assigned to the value 20. And then implicitly, there's going to be a link that hooks up this local scope to the scope of the function that follows the function around. And this is implemented internally in the browser or in Node, and so you won't see this, but sometimes the property here will be called parent. So this local scope here gets put at the front of this chain, and the chain is the links between all of the various scopes. And so this is going to be the scope chain. And the difference here is that the local scope was created at the time that we called the function. And this scope up here was created at the time that we created the function up here. So now, let's say that we're inside of this function and we're returning a plus b. So the JavaScript runtime, or the code that's running our code, is going to go and look up the value of a. And where it's going to find it is first it'll look through the local scope. It doesn't find it there, so it climbs up the chain and it finds it in the outer scope, or the parent scope, and its value is 10. And then for b, it'll do the same thing, except this time it finds it right here in the local scope, and its value is 20. And so the result of calling a plus b is 10 plus 20, and that gives us the result of 30. So a couple more things to point out here. First of all, hopefully it's clear that there's a chain of scope objects, and those scope objects will get searched for variables when JavaScript is trying to identify or resolve the values of our various variables. The other thing to note is that in this case, the local scope will exist for the amount of time that for the whole time that we're inside of this function here. But because it doesn't get used anymore, the local scope will get destroyed when we return from this function. But this scope here will never get destroyed because it's been attached to this function and follows it around throughout the function's lifespan. So as long as a scope object is being used, it will always exist and not be destroyed. Now, of course, this scope object was created for us automatically, and so we don't normally interface with it directly, but it's helpful to think about it as an object so that you can get a sense of what JavaScript is doing under the hood. Now, I want to show you another concept, and that is that this scope object can be shared by multiple functions. So let me get rid of this code here, and let's create a function called subtract. And that function will have a variable, we'll just call it b, and set it to 5, and this will return a minus b. Now, at the time that we create this subtract function, it will get attached a scope, and that scope will be the same scope object as is attached to the add function. So both of these now are referring to the same scope object, which has this one variable in it identified as a with a value of 10. So if we were to change the value of a in either one of these functions, the value would actually change for both function scopes. So the thing to remember is that scopes are just like regular objects, and that when we create a function, the function will get attached to a scope. So it will have kind of like a hidden scope property. And then when we call a function, it gets another local scope of variables. And when JavaScript looks up the values of various variables, it follows the scope chain to resolve the variable names to actual values.